Hello, my name is Brian Gallagher and I'm an SE working with Cubus, one of Juniper's Elite Plus partners in the UK. And today I'm going to run through a demonstration of the Mist dashboard and show you some of its AI capabilities. As you'll see when logging into the dashboard, your landing site is the Insights page with a today view as it focuses on current pressing trends. This Insights page gives you visibility into a current overview of your organization, including your sites, devices, applications and services, as well as important client information. A timeline will display usage statistics along with any site, client and AP recorded events, and it will engage with a very simple traffic light system of good, neutral and bad events in a unified network management view. So let's change from today to the last 7 days and observe that the timeline expands dynamically to show these events. We can also use the timeline to zoom in on specific events where some errors were shown, and you can notice that the site and client events now dynamically adjust to the filtered, focused time range. If you also know a specific time and date, possibly from a raised help desk ticket, you can enter this and then apply the filter. So let's just return to the last 7 days data and select the client events link on the timeline, and we will scroll down to see the client events. We can see good, neutral and bad events in a single view. I can select just the bad events and the data loads from the Mist cloud in real time, and we can then see that there are lots of negative events in the single view. So on this single event we can use the R2D2 client link to pivot to the specific insights page for this client. So let's do that for this event. And once the individual client insight page loads on the dashboard, you also get a location view on a floor plan of where this client is, which is really nice. And we also get extra telemetry information of the client event on the right hand side view. Here we can see the AP involved, we can see the RSSI values, we can see the SSID, we can see the band, we can see the description, and in this case a failing DHCP discover message on a particular VLAN. Now in this example I would normally expect a paperclip to also show alongside this timed out event. However, as this is an ongoing issue, the AP has rate limited the number of repeated packet captures to save on storage. I just need to scroll down to where I think there is going to be a packet capture. And there they are. So let me highlight this event. And this demonstrates the dynamic packet capture capabilities of Mist AI in recognizing problems. So to do this, Mist APs have a ring buffer built in that allows them to capture the bad events and send that data to your dashboard. And there are some great pros for this, in that there's no need to try and recreate the scenario again, or the need to send resources to remote sites to recreate the problem. Mist has already captured this information for you, and it's especially useful when it's an intermittent problem as well. Now Mist never captures payload, it only captures headers, so there's no concerns on security. If I scroll down on the right hand side view, you'll see that I can download this packet capture. So let me download the capture. I will open it in my Wireshark tool, and I can see all of the frames associated with this capture. I can apply a bootp filter and see that bootp requests or discover messages are being sent, but we're not receiving any offers. This is super useful in the troubleshooting process. Now let me return to the site level 7 days view. And now, because partners have a filtered observer view of the dashboard, I cannot show you that AP events would normally be displayed on the Insights page next to the site and client events. I mention this because it is a very important automated AI-driven feature for Mist. I will demonstrate this for you later, but please bear with me for now whilst we get to the appropriate part in the demonstration. If we look further into the Insights dashboard, we can see that Mist has visibility into the applications running within the network, and we can see that there are currently 34 applications detected. This section gives you usage statistics as well as user statistics in the form of transmit and receive and the numbers of users accessing a particular application. We can also see that Mist has visibility into Teams and Zoom calls, and we can see that there have been some latency, jitter and packet loss issues with some calls. Again, we will look at this through the demo. As we further scroll down into the Insights page, we come to what looks like a small section related to network servers, but to myself and other network engineers, these are hugely important. These metrics are used in two of the most important SLEs in Mist wireless assurance, the time to connect and successful connects SLEs. Now think about when you connect to a network. We have to run through the 802.11 state machine. Users have to firstly authenticate and associate, then get an IP address from the DHCP DORA process, then ARP for the gateway, and then perform a DNS request to verify internet reachability. There are lots of steps involved here, with lots potentially to go wrong. Each of the server metrics verifies if there are any negative values to help pinpoint a potential issue and then start the troubleshooting process. So let's look at some of these. Radius sees that there are a few successful attempts, but lots of failed attempts. So potentially something going wrong with 802.1x in this environment. DHCP shows lots of successful attempts and some failures, and DNS in the same vein. So are there any problems? We don't necessarily know. Are the negative counters increasing? We'd have to keep revisiting this. And once you identify it, why could that be? So now this is a major Mist feature. In order to focus on the client experience, Mist collects 150 plus events for every connected and clients attempting to connect to the network every 2 seconds. And this obviously produces huge amounts of data, too big for anything but machine algorithms to work on. Mist, and in particular Marvis, the AI engine, breaks this big data down into various processes occurring behind the scenes to correlate, aggregate, and then populate the Mist Assurance SLEs. The engine that performs this is the Predictive Analysis and Correlation Engine, known as PACE. And the PACE engine gives some insight into how powerful the Mist AI features are, providing network teams with a virtual help desk assistant and a seriously useful extra pair of hands. That's Marvis. As an engineer, Marvis provides me with the results from the PACE engine that saves me time identifying potential resources, devices and clients that need assistance, and in turn providing actionable intelligence to reduce the time to resolve these problems. Now, one way to access Marvis is from the little bot face at the bottom of the right-hand side of the dashboard. And when we open this, this brings up the natural language interaction with Marvis. And here we can ask questions and start the troubleshooting process, which we will do later in the demo. Another way to access Marvis is from the main Mist menu. And on the Marvis page, we can ask a question. This allows us to use a guided query language and choose from a series of options to interact with Marvis. The goal of Marvis is not to replace engineers, but to assist engineers with those mundane and repetitive tasks to have a quicker mean time to resolution. I mentioned earlier that we as partners have an observer view of the dashboard, which meant that AP events were not visible on the Insights page. Well, using Marvis, I can still demonstrate the beauty of an AI automated repetitive function that I, as an engineer, just would not have the time to perform manually. I can use the query language to build up a request of AP events with an AP event type of RRM, and I'll apply that filter. Marvis returns information on the RRM filtered events. Now this utilizes the MIST RRM microservice to regularly and dynamically optimize all of the AP channels and power settings. To do this, MIST APs have a scanning radio that constantly listens to neighboring APs channels and any Wi-Fi and non-Wi-Fi interference affecting them. The RRM algorithm runs every day at approximately 3 AM based on the associated correlation of the RF data from the capacity SLE, and optimizes the AP power and channel selections. It doesn't just do this once and forget. It constantly monitors to ensure that the client experience is being improved from these RRM events as well, and it is activated quicker if users are seen to be affected and an event-driven change will occur, as you can clearly see by the time shown on the RRM filter, different from 3 AM. This is one of the real benefits of an AI engine. It performs a very repetitive function that would be very tedious and error-prone for engineers to perform. And as we've already mentioned, Marvis ingests 150 data points every 2 seconds for connected and connecting clients, and the Marvis Actions landing page, to many engineers, is the getting settled in, first cup of coffee, network review screen at the start of your day to see what's going on and then prioritize your task list. Let's have a look at a couple of examples from the information gathered by Marvis and see how powerful and time-saving it is. So from a layer 1 perspective, Marvis can report bad cables. Here we have an AP reporting that a port on a switch has a bad cable. This AP link allows you to pivot to the utility section and run a cable test on the device to confirm this before replacement. We also have AP actions, and here we can see that a failing AP is reporting that a health check has failed, and the RMA process can begin with the AP remaining working in the network, and once the new AP arrives, you can swap it out, apply the same WLAN template, and minimize the potential client downtime or effects in your network. That's a very cool feature. Now, MIST also uses the collected data in the primary MIST dashboard to populate the service level expectations, or SLEs as they're known. This is where we have the ability to proactively monitor wireless, wired, and WAN activity. So let's look at wireless for the last 7 days. Now, machine learning runs on this collected data and is written to these 7 SLEs that present the user's experience on the network in a simple, consumable manner. Each SLE has a description that can be viewed and a correlated timeline with other SLEs. System and configuration changes can be seen in blue or green triangles along the timeline. The SLEs have values that can be set to what is a baseline for a particular network. For example, if I click on settings, you can see the time to connect SLE value is set to 2 seconds. Now this can be changed with a slider in your network for a less or higher value, depending on your network parameters. For successful connects, there's no histogram because it's a binary success or fail attribute. The coverage SLE has been set to a neg 66 dBm goal here, but is currently only 68% successful. So however, still many clients receiving a weaker signal, and this may indicate more APs are required across the network. Each of the SLEs are made up of classifiers that indicate a percentage or value of what makes up the indicator of a potential issue to look at. So over here, although the time to connect SLE is sitting at a 92% success green value, this is a measure of how seamlessly clients connect to the network, and the closer to 100%, the better. So let's look at this time to connect SLE closer. So when we click on this SLE link, it opens the root cause analysis screen. And from this, we can see that 58% of the time and 37% of the time for DHCP, these are the main causes of the problems. And bearing in mind that we saw DHC problems for a client at the beginning of the demo, let's look specifically at the DHCP and the unresponsive issues or subclassifier. So we can, at this point, we can run through statistics, timeline, the distribution of devices, WLANs, types, APs, but we land on the affected items. And on the affected items page, we can select this client and retrieve a summary of those parameters. So from a coverage perspective, the client encountered poor wireless coverage nearly 50% of the time due to weak signal strength. It was slow to connect 41% of the time because of slow responses from the DHCP server. And it failed to connect on 14% of the time, primarily due to authorization problems. Needless to say, this user may not be very happy right now. So let's see what Marvis has found. And it's as simple as asking Marvis to troubleshoot the client Denali. And Marvis goes off and collects the information for us and returns some facts of a sticky client behavior or poor coverage. So let's click on poor coverage and see what it says. So from a failure timeline perspective, we can see when things are going wrong with the weak signal. From a scope of impact perspective, we can see which APs are affected. And from a recommendation perspective, we can see that Marvis is suggesting that we maybe don't have sufficient access points covering the site. And also to check if the device is sticky, i.e. it's connecting to APs at a lower value. So let's just have a think, what else can Marvis do for us? Let's take a look at how Marvis can assist in real-time applications like Teams and Zoom sessions. I'm aware of a user having issues with Teams, so I'm going to ask Marvis to troubleshoot Teams calls for a particular user over the last 7 days. And it returns multiple calls. If I select this last call, the network diagram comes up. Now, because this network has a full stack Juniper Mist approach, the network administrators can have visibility from the client all the way through to the cloud applications to be able to quickly and easily pinpoint where the problems are. In this case, the network devices don't appear to be the issue. So let's explore the client and the client issues that exist by expanding this drop-down box. So we can see the user reported a poor rating, but not much information other than. So we may need to further explore this. So let's continue to ask Marvis to troubleshoot the client generally. And it goes off and collects the data for this client. And it's suggesting in this case there are issues with poor coverage. So in this context, we've already seen that there is 100% weak signal for certain clients in the network. And Marvis has come back and said that there are poor coverage issues and devices are connecting at low signal strength. And it's repeating this poor coverage element yet again. And if we select it, we can see that the recommendation is to ensure sufficient number of access points are covering the site. So we possibly need to look at our coverage and potentially capacity again. So for now, I'll minimize Marvis and let's look at our wired environment. Now, from the Mist main page, we jump to switches and a list view, and to view our site inventory. Here you can see green connected devices or red disconnected devices. We can also see device names, IP addressing, the models in the network, and which APs are attached to which switches, if there are any wireless clients, wired, the version of software running, and a direct link to the switch insights page. We can also jump to the topology to view the links in the network from various devices. So as this site loads, pulling in the information for us, we can see that we have some parameters up the top that we can view. But we can also click on this client, this switch at the bottom, which is suggesting there are two devices. And as it pulls the information for the two APs, we can also see that there are no connected clients on these APs. We can also use the search function. And let me search for the device called Android. And if the Android device is online, it will return that information for me. So I can search for this client and ask Mist to produce a network topology for us. So now we can see there is a very detailed picture what Mist presents as the flow of the packets and how the Android device moves through the network. This is a great way to update any out-of-date documentation after any recent adds, moves or changes, or just being able to visualize your connections. So jumping back to list view, we can see that one of these switches has a slightly different character being used, and also the Mist APs look different from the others. So if we move this down, we can see that there are actually two switches, and that's because this is a virtual chassis. There are also no APs on node 0, but there are two APs attached to node 1. If I click the switch and bring up the front panel view, we can see that there are two switches, node 0, node 1. We can see that we have trunks configured. We can see that we have wired clients, we have cameras, and we have uplinks. We also have VCP connections on the ports, on the 10 gig ports on the end, and we can verify that there are two APs connected, as it suggested, on node 1. We can see a summary of the properties of this switch, and that the configuration is managed by Mist, meaning that Mist is the single source of truth and will overwrite any config changes executed on the CLI. We can see device naming conventions, we can set IP configurations and port configuration informations. Now as we scroll down, we can see the networks and port profile section bring in the use of templates. And this indicates, the star or asterisk indicates that these items were inherited by higher level templates. So the types of templates we have are organization templates, where all devices can inherit top level parameters like NTP, DNS and radius. We can have site level templates, which allows site specific settings to be inherited by groups of devices. And we also have switch level configurations, which can override higher level parameters where unique configuration is required to give you ultimate flexibility. As we scroll down, actually, we'll have a quick look at this really cool feature, dynamic port configurations. So these colorless or dynamically assigned ports can look at an LLDP system name of LD underscore. It can look at an LLDP description of Mist coming from the LLDP packets. And if they match in this case, an AP configuration profile of a native VLAN of 1, but it'll be a trunk carrying all VLANs as an edge, can be applied dynamically to a port that is assigned as a dynamic port. As we scroll down, we can see VRF information support, and when we get into services, we can see grayed out areas under services that displays the configuration has been inherited from an org or a site level template. The benefit of this is scalability and ease of deployment instead of lots of repetition. All the CLI conversion of complex command syntax is done under the hood. So we can also see that routing is supported, static, OSPF, BGP, and switches still have access to the CLI configuration commands and even additional CLI commands via the dashboard. But remember not to make these changes on the CLI, otherwise Mist will overwrite them, as it is the single source of truth. CLI access, however, is still great and accessible from the devices, but use it for verification and troubleshooting. Now, lastly, on your switches, let's go to the top level and go to our location, and we can see a floor plan, but without 2.4 or 5 gigahertz. Clicking on the 5 gigahertz option brings up a heat map display, and this is useful to validate the switch cable runs or whether the appropriate load balancing has been set up for the APs to ensure failed APs don't result in a total coverage loss. So if I fail this switch, we can see that that is what happens. We have a coverage loss. So roaming could be affected. Now the last feature to demonstrate is location. So if I jump across to location and live view here, we can choose the office floor. And on the office floor, we can see our clients in real time moving around the floor. And we can see that we have app clients and Wi-Fi clients. We can also see that we've got various assets that we may need to track and locate quickly allowed here. We can also see devices, APs, switches, and WAN edge devices. We can also see beacons can be configured to interact with our clients or in a store and send them an offer based on location. We can also see zones can be configured to put in occupancy limits, which was useful in COVID times. So if we go to location diagnostics, we can click on the beam density map, and it basically gives us an app, BLE and Wi-Fi experience view of the network from a particular device perspective. So if I select either app, BLE or Wi-Fi in this case, and change this to a 24-hour period, we can see the average and maximum RSSI values for all of our Wi-Fi clients where they have appeared during this time frame. So if I go close to an AP and a red value, we can see that we've got very strong signal strengths. If I move further away to devices, I can see that I've got very weak signal strengths. So this is great for any coverage and capacity planning exercises. So the last thing for me to do is to have a look at the analytics and go to occupancy analytics for this floor, and we can look at client density information, and we can see that we've got two areas here where there are higher density of users which we can use to verify compliance with configured zone allowed occupancy numbers and send alerts if they're not being met. It could also be that there were two larger meetings going on in these areas, and it could indicate that the AP numbers need to be looked at in future to cope with extra capacity. This has been a short introduction to Mist, and there is so much more available to demonstrate the capabilities of Mist and Mist AI. We are more than happy to provide equipment from our own demo stock for you to experience firsthand the benefits of Mist, and we can also engage with the Juniper team to arrange a POC for a project and work with you so you can see how Mist can provide insights into improving the client experience on your network. For now though, I'd like to thank you for listening and hope that you found this presentation of interest.